Here we're going to use RSLogic's MicroStarter Lite software to examine some of the data files for a MicroLogix 1000 PLC. Looking over here at the PLC itself, we see it wired up to a series of switches where I can simulate different inputs. You can see the telltale LEDs light up as I flip the inputs on and off, as I energize them and de-energize them. What we're going to do is examine the statuses of the bits associated with inputs and outputs by taking a look at the data file listing over here in the left-hand pane of the RSLogix software. If we examine, for instance, the I1 input file, I'll double-click that, brings up a dialog window, and in this dialog window you see a series of zeros. This is representing the input file element 0, word 0, and these are all 16 bits of that word. Right now we're looking at bit 0, which happens to correspond to our first hardwired discrete input. If I turn that switch on, you'll notice that 0 changes to a 1. If I turn the next switch on, you know that 0 changes to a 1. And the next switch, and the next switch. I have 6 discrete inputs on this PLC, and I've now turned all the input switches on. You can see the first 6 bits, bit 0 through bit 5, are all now 1s. So I turn those switches off. One at a time, you'll see the 1s turn back to 0s. Now, the output as well can be viewed over here in the data file status. I pull this up, pull up another dialog window, and in here we see once again another element, another word with 16 bits. Now this represents the output status of the output bits for the output channels on this PLC. This particular model of MicroLogix 1000 PLC only has 4 discrete outputs, so I'm only going to be using the first 4 bits, bit 0 through bit 3. Right now my cursor is over bit 0. If I enter the number 1 and press enter, you probably heard it click. That was the sound of that output discrete channel coming on. If I go over to the next bit and I enter a 1 there, you'll hear another click from the PLC. I've just turned on the first 2 bits of the output. If we look over here at the PLC itself, you see the first 2 discrete outputs are energized. That's because I just manually forced them to be a 1 status inside the processor. So turning back the screen. So what we're looking at here is the I/O, the bits representing input and output of the channels on that PLC. I want you to notice there is no program in this PLC at all. I can pull this dialog window down. You can see there's only 1 rung and it goes to an end statement over here. There is no ladder logic programming here whatsoever. All I'm doing is I'm directly reading the input bits and the output bits. In this case I'm setting the output bits, and that's causing the output to turn on. Or in this case, if I enter a 0, I can force that output channel to turn off. Here we go, another 0. And if we turn to the PLC, you'll notice that both of those output channels are now off. So what the PLC does as it executes its program is it goes through and it scans all the input channels and it updates these input bits according to the electrical status that it sees at the wired input channels. Then it executes the program itself. In this case, as I said, there is no ladder logic program. We can take a look at this and see that there's really only 1 rung in the program, and it terminates in an end statement or end instruction. So there is no logic programmed into this PLC at this moment. So after it executes the program, if there is one, then what it does is it takes a look at the bit statuses of the output file, and it writes those or sends those to the output. In this case, this PLC is a relay contact output, so it'll either energize or de-energize the output relays according to the status of the bits it sees here. So reading the input, running through the program, writing to the output, and then it repeats the cycle again. There's also other steps of the scan cycle where it does some overhead communications, memory management, things of that nature. Those aren't terribly important to us right now. I wanted you to see the relationship between the input bits and the electrical status of the inputs, and likewise the relationship of the output bits to the electrical status of the outputs, with no program in the PLC whatsoever.